Welcome to our Splunk search processing language tutorial on the sichart command. The sichart command stands for Summary Indexing Chart Command, and it's a powerful feature in Splunk used for statistical process control charts. This command creates control charts for quality analysis and process monitoring by populating summary indexes with statistical data for visualization. The sichart command is essentially the summary indexing version of the regular chart command, designed to enhance performance and enable statistical analysis of your data over time. Let's examine the basic structure and syntax of the sichart command. The required syntax includes the sichart keyword followed by optional parameters and a statistics function with a by clause. The optional parameters include sep for field separator string, format for time format specification, cont for continuous aggregation, and limit for maximum result count. The general structure follows this pattern: sichart, followed by optional parameters in square brackets, then your statistics function, and finally the by clause with your field specification. Understanding this syntax is crucial for implementing effective statistical process control in your Splunk environment. The sichart command supports a wide range of statistical functions organized into different categories. Basic statistics include average, count, sum, minimum, maximum, and range functions. Advanced statistics encompass standard deviation, variance, median, mode, and percentile functions like perc95 and perc99. Counting functions include distinct count, values, list, first, last, and earliest functions. Additionally, the command supports sparklines for trend analysis and creating mini charts within your data. These functions provide comprehensive statistical analysis capabilities for monitoring process performance and identifying variations in your data. Here's a practical example of how the sichart command works. When you run a search like index equals weblogs pipe sichart average response time by host, this command populates a summary index with average response times grouped by host. The beauty of this approach is that you can then use the regular chart command with the exact same syntax to query the summary index for visualization. For instance, chart average response time by host will use the precomputed summary data for fast visualization, dramatically improving performance for repeated queries and dashboard updates. Statistical process control charts created by sichart contain several key elements. The upper control limit, abbreviated as UCL, represents the statistical boundary indicating the upper threshold for process variation. The centerline shows the process average or target value used for comparison. The lower control limit, or LCL, represents the lower statistical boundary for process control. Finally, data points are the actual measurements plotted over time. These components work together to provide a visual representation of process stability and help identify when a process is operating within normal statistical boundaries or when special cause variation occurs. The sichart command offers several advanced parameters for enhanced configuration. The sep parameter allows you to specify a custom field separator for multi-value fields. The format parameter lets you define the time format for timestamp fields in the output. The cont parameter, which accepts true or false values, enables continuous aggregation across time periods. The limit parameter sets the maximum number of results to return, helping manage performance and output size. Here's an implementation example. Sichart format equals %y-%m-%d limit equals 100 average CPU usage by server name. These parameters provide fine-grained control over how your statistical data is processed and presented. The by clause in sichart enables powerful field-based grouping and aggregation capabilities. You can group by a single field for simple categorization, such as sichart count by status. For more detailed analysis, you can group by multiple dimensions using multiple fields, like sichart average response time by host, status. The by clause also supports time-based grouping for trend analysis, allowing you to group data by time intervals. These grouping concepts are fundamental to creating meaningful statistical process control charts that segment your data appropriately for analysis and monitoring purposes. The sichart command integrates seamlessly with Splunk's summary indexing workflow. The process follows 4 main steps. First, aggregate data using the sichart command to perform your statistical calculations. Second, populate a summary index with the results using commands like collect. Third, query the summary index for fast visualization using regular chart commands. Fourth, generate control charts and reports from the pre-computed summary data. This workflow is typically implemented as a scheduled search, where you regularly run index equals main source equals logs pipe sichart average CPU usage by server name, then pipe collect index equals summary source equals CPU stats. This approach significantly improves dashboard performance and enables real-time monitoring capabilities. The sichart command serves multiple real-world applications across different domains. For performance metrics, you can monitor application response times, CPU usage, and memory consumption using control charts to identify performance anomalies. In quality control scenarios, you can track manufacturing processes and service quality metrics for comprehensive statistical analysis. For trend analysis, the command helps identify patterns and anomalies in time series data using statistical boundaries to detect unusual variations. In business intelligence applications, sichart creates summary indexes that enable fast dashboard queries and executive reporting, providing stakeholders with timely insights into key performance indicators and operational metrics. Successful implementation of sichart requires following several best practices. For scheduled execution, run sichart commands at regular intervals to ensure consistent data population and maintain up-to-date summary indexes. Implement proper index management by monitoring summary index sizes and establishing retention policies to control storage costs. Focus on performance optimization by using appropriate time windows and field selections to maximize efficiency. When interpreting control charts, points beyond the upper control limit or lower control limit indicate special cause variation that requires investigation. 7 consecutive points trending upward or downward signal process drift that needs attention. Multiple points in outer zones suggest process instability. These guidelines ensure effective statistical process control and reliable monitoring of your systems and processes. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.